Hey guys, thanks for tuning in. Today we're going to talk about why I feel BMWs are now reliable. Okay, so this is the BMW B58TU engine. So there's a few arguments I'd like to make in comparison to my N54 motor in my E90. I believe this is going to be much more reliable, and I'll explain why. So now this is the direct injection pump for the fuel system on this B58 engine, and it leads to this fuel rail here, and there's updated injectors as well as a much more beefy fuel pump, high pressure fuel pump. Now my main argument regarding why the N54 motor in my E90 wasn't as reliable is the fueling system that they implemented. To start with, this is the high pressure fuel pump that was introduced on this engine when it first came out. So here's the fuel injector that came with this engine. So these two parts alone can be considered the Achilles heel in terms of what is going to cause this engine to be less reliable. Now, you got to think about the time frame when this engine was introduced. It was introduced in the mid-2000s. Basically, it was developed in the mid-2000s and it was introduced in the 2007 model year for North America. You also had the introduction of the turbocharger. And not just one turbocharger, but two turbochargers. So besides the BMW 2002, this was the first year that they got back into turbocharged technology for their cars because they wanted to be ahead of the competition. So this car didn't have just one turbocharger, but it had two turbochargers. It was twin turbo, equal sized turbos. So first of all, having two turbochargers is overkill. You wouldn't necessarily need that for the type of power this engine made. They learned that after the fact, I would say, but it left for a ton of tuning potential, and that's why these engines are becoming legendary. But basically, you know, the design of this is small, it's doing a lot of work, it's gonna get to generate a lot of boost and a lot of heat. The wastegates can wear out. That could be one of the issues you'll face with one of these engines, because it didn't need to be a twin turbo to make 300 horsepower. It was over-engineered and they were playing it safe, getting back into the turbocharged game. So now you have to ask yourselves, why did they put a high pressure fuel pump on this motor that's good for 500 wheel horsepower when the engine is going to make 250 wheel horsepower? Why does it have a piezoelectric injector that's like revolutionary technology that can flow all the way up to like 1,000 wheel horsepower? What was the logic behind that? Well, they were getting into new technology, so they kind of went overkill, I guess you could say. And it took 12 iterations of this injector to find a reliable version. It took many iterations of this high pressure fuel pump to finally get a reliable version. Another thing is this high pressure fuel pump is also driven by the timing chain. It's not just driven off the cam and sitting on top of the motor. So that adds complexity and potential wear and tear. You have guides and everything just to run this. So basically, because they decided to couple direct injection with turbocharging, we led to some reliability issues and they got a bad rap. Everything was overkill. You even have a low pressure sensor just to see what your low pressure fuel would be. This doesn't help the customer or emissions, it just helps BMW get more data when they're trying to troubleshoot why they're having issues with this new technology. So you have parts on everybody's car, in my opinion, that are just there to help the engineers gather data from multiple cars. This is no longer necessary. In terms of boost control, they were using vacuum lines and diaphragms to control things. And nowadays, everything's gone to electronic for reliability standpoints, electronic wastegates. One surprising thing that they did at the same time, as well as introducing direct injection technology and also turbocharging, is they put an electronic water pump, which they've actually moved away from and went back to mechanical on these new engines because it just wasn't working out. And they realized that the efficiency gains are not worth it. I'll show you on my B58. Now you have this. That's the camshaft for inside the engine. And if you guys weren't aware, these cars have a regular throttle body and they don't vary valve lift to control how much air gets in the engine. So in my opinion, the Vano systems had enough time to be perfected by the time this engine was introduced. So there was no issues there. But one level of complexity I think they want to avoid was going with Valvetronic, where they have a gear motor here that changes the lift of the intake valves depending on throttle position to control how much air makes it in the engine through the intake manifold. They left that off because they just probably figured that's just too much for the turbo motor, but they put it on the NA N52 motor, but skipped direct injection. They left direct injection to the N53 in Europe, probably just for development purposes, and they stuck to port injection on the NA N52. So they were kind of deciding, okay, We'll give some features to the N52, some features to the N53 and N54, strictly for the sake of experimenting with how reliable each setup will be and not overwhelming the customer with potential issues. Before we go back to the B58, I want to kind of show you some lessons that have been learned along the way. Look how tight this engine is in the engine bay. Look where the coolant bottle is placed. Right by the radiant heat of the turbos. Where do they split? Right about here. Where is all the engine looming and wiring going? Right above this very small area, right above the turbos, that could easily be damaged due to heat cycling. The valve cover design is a little odd and overcomplicated and a little bit tall and close, so it could crack due to its shape in the integrated PCV, etc. Very tight here, and overall this engine bay, because the cars were smaller back then, didn't allow for heat dissipation and heat management, and therefore you had boost solenoids failing. You could have issues with cracked or warped valve covers. You could have issues with your fuel injectors just due to design and the high pressure fuel pump or the way it gets driven. All this stuff was at that pinnacle time when all automakers were going nuts on perfecting the internal combustion engine before the big wave of EVs were about to come, in my opinion. Coming back to the B58, pay attention to right here. You got tons of space, tons of area for heat to naturally make its way up and out. You have a heat shield here just to even protect the air box, even though you have almost 4 or 5 inches of room. And funny enough, there's even a turbo blanket over the turbo just to really help with keeping heat under control, as well as a heat shield above the turbo. And look how thick that heat shield is, oversized and redundant in my opinion. Check out this heat shield right here, just protecting the lower air box. So there's so much room, even with my big camera and my huge lens, I can fit it right down in here. With regards to room in front of the engine, looks like before you even hit the rad is in about this far. So from here and here, you got like 8 inches of space, and there's lots of area to manage stuff that could be potentially affected by heat. This valve cover design is very generic, flat, simple, and the thickness of it is only like 1.5 inches to avoid warpage, in my opinion. The reinforcing and bracing on the plastics, even though they haven't probably gone a long way with regards to plastic life expectancy in terms of material build, the reinforcement side of it is kind of, it is what kind of makes this ugly when you pop the cover off and why the cover is so huge. That's why I made the thumbnail, just to show how funny it looks in the E90. But they just went for reinforcement, and they kept anything that could be damaged by radiant heat away from heat. That's not possible with this because there's a heat exchanger inside, but they reinforce like crazy. Pay attention to where the coolant bottle is. It's over here, well away from the turbos. Why would you keep it by the turbos to get heat soaked and heat cycled like crazy? It's not the coolant inside them that would cause them to fail, it's the placement. And then you have coils that have, even though they're a dumb coil, they're just so huge that they can store extra power in the head and never fail on you and cause false misfires. You have solenoid-based fuel injectors that they had like 3 iterations to maximize their reliability on, to where they're no longer an issue at all. You have a very simple high-pressure fuel pump that's literally just 2 bolts. It's probably that big, and it bolts onto the valve cover and gets driven by the cam. Super simple, no chains or anything or guides or vibrations to cause it to fail. In comparison, kind of crazy. So now, in my opinion, starting with the E36, when they switched over to the use of plastics in their cars, you could argue it was for recycling or for lightweight purposes, etc. They didn't necessarily use lightweight materials in the engine bay, but they made them so they could be recycled and maybe used as under trays, other pieces of hardware, etc. But from there, they had their many years, their 20 years or so, to really think about placement and rad hose placement, radiated heat placement, etc. for the sake of heat management. Now, you had the N54 where they learned a whole bunch of stuff on. Then you had the N55 where they went to Valvetronic as well as turbocharging, and they went to a single turbo because there's no point putting dual turbos when you're trying to make 300 horsepower. And then they made the B58, they ran it in the F30, and in the F30 they refined a whole bunch of stuff to get it to where it's dead reliable now at this point, in my opinion. The only major change is they went to a high pressure fuel pump that runs at double the pressure for efficiency. But even still, with that fuel pump, they have the technology figured out where it wasn't an issue, and they may have had some input from Toyota because they put this engine in the Supra. So in my opinion, the development of the internal combustion engine from BMW, specifically the inline 6 motor, is done. And if they're going to try to get more power out of them, they'll couple on mild hybrids or go full electric. And funny enough, this 2020 model year has been updated with mild hybrid technology for 2021. And that's the way they improved on this. They're done refining this. They got the maximum possible fuel pressure and the reliability sorted, in my opinion. You got a heat exchanger built into the intake manifold. Development of this is not going to change a whole lot. They've been doing this for a couple generations. So now they've had 15 years to refine this to the point where they've figured how to make this reliable for the customer. Lots of room, lots of reinforcement, better design, etc. So this engine is going to be reliable. So check out that mileage, just under 15,000 miles. I've had it for a year and a half almost, and I've had no issues. Mechanically, interior wise, no vibrations, no nothing. It was just dead reliable. And this is a first model year if you think about it. The likelihood of that used to be low because they would be trying out something new, but they're done trying out new things with the ICE engine, in my opinion. In 1.5 years of ownership, I literally had just one problem. I had a little bit of bubbling on this trim here due to the Texas heat, and I had that replaced under warranty. It was the only reason I visited the dealer at all. So I drove this for a year and a half for 15,000 miles and I didn't have any issues. The interior didn't rattle. It made for such a good daily driver that I didn't even bother tuning it or anything. I just enjoyed it as it is because it's quick enough. That's kind of odd to say as an enthusiast, but truly it was a great car. No rattles, no squeaks, just really refined, well put together and no issues. So when was the last time you heard about that? A first model year being introduced with an updated engine and all that, where you have zero issues, just dead reliable for the entire duration of 15,000 miles. That's just kind of unlikely, I would think. So what's funny in my opinion is BMW engineers, when they're going into uncharted territory, tend to double the capacity of an item just for redundancy purposes. So this setup was good for double the horsepower. The injectors were, everything was just overbuilt, the bottom end, etc., because they'd rather overbuild the engine to not blow up than be embarrassed by it failing. That's why you can get 200,000 miles out of these easily and they'll still seem like they're brand new. But it's the stuff around the engine that would fail due to heat cycling, primarily. Now think about it from a design and sales standpoint. Will they sell a whole bunch more cars because they put a turbo blanket on here and they left this much space? No, I just feel like in the pursuit of reliability, they would rather give people a car that was reliable if possible. And if you had to ask me, that's the reason why Toyota even allowed to partner with BMW, because they knew that this was mostly reliable at this point. So here's a scenario for you. Imagine this is the N52 engine. Imagine that this chassis had changed, but the engine had not. And they kept using it for 15 years. How reliable do you think that engine would be, assuming that they had the space around it to deal with heat even better as well? 15 years, it would basically be one of the most reliable cars you can buy on the road. Now, after that thought experiment, think about the 2021 Lexus IS 350 with the 2GR motor in it. What have they done? Exactly that. They just refined that motor over and over and over. People are annoyed that they haven't gone to turbocharging because they're behind the pack, but Lexus customers would rather have a dead reliable car than deal with issues, and they're okay with the trade-off in performance, in my opinion. So in my opinion, Toyota doesn't innovate. They hold off on their product development for the sake of reliability, and BMW innovates and they take risks, but people expect performance and they have to. Now, give them enough time where the technology is not going to improve a whole lot more because the internal combustion engine's going away, and you reach that pinnacle where everything is refined and perfected and efficient, and you've had 10 years to really work out all the issues anyway, and it's going to be reliable. These plastics will still fail, don't get me wrong, but I believe by the way they've placed things, they won't fail at 60 or 70,000 miles, they'll fail at 100 to 120,000 miles. And that's not a big deal compared to like major things like injectors and fuel pumps failing. Another point before we look at this is I believe that BMW also tries to put their random technologies into the 7 Series and eventually trickle it down whenever possible. So this is a crankshaft out of an N54. If you look at it, you have 2 counterbalance shafts here, you have 2 counterbalance shafts here, and you have 2 counterbalance shafts here. The journals, 2 of them are always pointing in the same direction, right here. So you have 1, 2, 3. What that means is at every 120 degrees rotation of the crankshaft, you can have one set of cylinders firing and canceling the vibrations out of the other ones in the system, so that overall this is inherently balanced. You don't need a balanced shaft driven by a chain, and you don't have to worry about harmonic disturbances and vibrations that can vibrate and destroy things. Because if you have too much harmonic vibration, constantly vibrating this left and right, heat cycling like crazy, eventually it will become brittle and shear and shatter in different points just with time. So what happened is they took the same timing chain module when they brought out the 4-cylinder N20 without much change on it, and it caused these to fail, the chain to stretch, a whole bunch of things that they hadn't planned on because they didn't really develop the 4-cylinder engine for a long time, and you had failures. Then they moved to a balance shaft on the new 4-cylinders to help mitigate some of those vibrations and to help with reinforcing this and life expectancy on the 4-cylinder. But unfortunately, there's an intermediary shaft bearing like on the old 996 Porsches that may prove to be problematic as well. So this argument is for the inline 6 version of BMWs. I believe they've perfected it. The 4-cylinder version where they cut off 2 of the cylinders, they're still working on it, but I'd say give them like 3, 4, 5 more years and they'll get to the same level of reliability there. The V8s, they've been running the N63 from the V8s for the longest time now, for 10 plus years, and they have so many technical updates that they're not really changing that engine, they're just improving on it. So it used to be super unreliable, but they're just gonna have enough knowledge now to reach the point like Lexus where they've ran it for 15 years and all the issues will be worked out, and even those will prove to be somewhat reliable. But this video is about the inline 6. If you ask the average person, does that look super strong and like crazy overbuilt to make 700 something horsepower at the wheels? I think they would say not really compared to looking at a standard 4-cylinder 120 horsepower rod. Sure, they're forged and they're fractured and all that, but really this is, in my opinion, the reason it's super strong is because of how balanced the inline 6 naturally is. You just have forces canceling themselves out based on the inherent design, where you don't even have to think about anything else. You don't have to worry about harmonic disturbances and whatnot because of the natural design of this. That's why they all hit 200,000 miles. They'll last just as long as a Toyota engine besides all the technology around them. Now, if I concluded this video here, I'm sure there'll be a bunch of people saying, well, that's all well and good, but you know, all the modules in the car break eventually and they cost you a fortune. So regardless, from an electrical standpoint, you're gonna face tons of repairs down the line. I don't think that's true anymore. You have to take my word for it, but this is from a modern BMW, from a G series BMW, and it's an iCam module. I was thinking about retrofitting this into my G20, but regardless, this is all metal and it's designed to manage heat and has a beefy power supply inside of it for what it is. The charging circuits in these new cars are much better. The battery selections are much better. They even supplement them with a lithium-ion battery. If you were to see an older module for an E-Series car, it would be plastic and it would just be clicked into place with a plastic housing, and then they would be damaged by low voltage situations. So I think from about 2007, mid 2007 and onward, those issues with regards to burning up modules are basically gone. 2009 and newer, you don't really hear about people just frying modules for no good reason, because they helped fix the charging circuit and they chose better batteries and supplemented them with start-stop technology, and they can leverage those batteries, etc. So after a year of using this car, do I recommend it? I do. It's more like a 5 Series and very refined, and as you grow older, as you get into your mid 30s, late 30s, early 40s, you may still find this is a suitable size car. It's very fast, very fun to drive, but mostly refined. It's been spared quite a bit from the crazy grills on the modern BMWs, but I believe that it's also even starting to look a little bit dated just because of that. A couple things have to pan out, so don't hold me to it, but this may be the last time you guys see this car on the channel. I'm thinking about getting rid of it, but for a good reason. And I'll have to think about it as well, but you may see a clip right now. All right, guys, that'll conclude this video. It's not my usual format, but I wanted to make a point because I've seen other people talking about how BMWs just keep getting worse and worse. But you know, like, I'm not trying to suck up to them or say anything special about them, really. I'm just going by facts here. You don't get to 15,000 miles with 0 issues unless they've worked the issues out, in my opinion. If this is the first video you're catching of mine, please consider subscribing. I do upload regularly. Thanks for watching.